how do you evaluate traditional, um, how do you evaluate LLMs and how does that differ from traditional ML applications? Well, standard ML applications have well-defined objectives, um, and when you think of things like accuracy or precision, recall, F1 score, etc., you're doing comparisons with a target label, right? So maybe you have a recommendation system where you're predicting what the viewer would like to look at. Or if you're just like classifying an output or a sentiment, right? Um, this gets harder for LLMs. And in fact, that's where LLMs shine, right? Because um, they shine in providing free range outputs. But that means it's harder to evaluate. Hallucinations are new. Um, and then the perception, though, is I would say in some cases it's similar to self-driving cars on a much smaller impact scale, um, where if you see an LLM that's it's maybe trying to sound smart or something like that, or it's sounding political in a direction that you wouldn't want it to, you might feel really bad about it, and you might think that it's doing it on purpose, or maybe the folks that train the LLM purposely introduce some bias into it and things like that. And as a company, it's also bad because then your downstream customers might see something awful and it might cause churn, right? So these are all the complicated aspects, and there are potentially more aspects um, depending on your use case that you need to account for and evaluate. So overall, how do you do LLM evaluation? Um, so, when you're developing a new large language model, or this is what you see in the literature when you're looking at how models perform, right? There are various representative tasks. There are things like empty bench, and there's just a bunch of different specific data sets that you can evaluate on and see how well your model is doing. Um, but in your specific use case, you might want to look at very specific examples and not so much evaluating your model or like general evaluation, right? So you might evaluate against hard tasks, things that are easy for humans but that are hard for LLMs, um, and then you might try to do evaluations across a variety of scenarios that capture a universe of user inputs. Uh, and you might also look at things like ethical evaluations, which more sort of align with the security or safety side of things. This is just an example here. I like this example because it's pretty non-intuitive, where you ask the same question. One of the, I think this was GPT-3, which said that if you smash a mirror, you will get 7 years of bad luck, um, which is, it's not a very nice answer. They probably got it from the training data. Right? So these are things that you need to be careful about. Okay, so what are the various aspects to evaluate? The first is the prompt itself. So how's the prompt doing? Um, Embeddings, how is your retrieval happening for RAG? You have various model parameters. And then there's also this aspect of data storage. So with data storage comes things like metadata, also how the document parsing is being done. Um, these are the various app evaluation components just visualized here. Um, right? So you have the LLM, you want to evaluate the prompt, the document store, the model parameters, the cache history. So whether it's your application is adequately able to preserve past conversations um, with customers. So how do you do task-specific evaluations? Um, so what you could do is you could have your app output certain answers, maybe 100 answers. You could have it in your data set if it's already from production. And then you can have human labeling to label them as correct or wrong, depend on the assigned criteria. You could have string match, um, but for this case, you would need an exact, like the actual answer, which is not usually used, but it's like a good starting point. Um, you could have, in a similar vein, F1 score, which is a better version of string match if you actually have the gold standard answers. Uh, and then you can also have metrics like Rouge score, which is used, or Blue score, these sorts of things like translation and summarization. There's another upcoming idea which is pretty cool. So it's using LLMs as a judge, right? So you can have a certain prompt for LLMs to, um, like as a judge LLM, um, and then you could have this judge to basically to see how good the answer that's output is. Um, so there, and then the other thing that you can do is you could use various uh, LLMs to judge their own answers, sort of like peer evaluations in a round robin manner. And so here you can see this is from a paper from the MT Bench, which is like one of the first papers introducing LLM as a judge. And so over various tasks, you can see, in this case, GPT-4 performed much better than some of the other modules. This is an older paper. Yeah. Any questions so far? I remember somebody was asking about evaluation. So I want to make sure that, if you have any questions, I can answer them. So there are various evaluation tools. One of them is Ragas. So this is where you can evaluate without a ground truth answer. And so there are these basically four kinds of metrics. Two of them are related to retrieval, and two of them are related to generation. Um, one is basically seeing how good is the retrieve context relative to the query that you ask. And the other one is to see, hey, now I have this context, and then how useful is this generation. So there's actually this interesting concept of a triad that you can have, because you have three aspects. You have the query, you have the context, and you have the output. So the triad is basically comparing the query and the context, and then the context and the answer, and then finally you can compare the query and the answer. Right? So three types of metrics. Um, Through personal experience, I would say that you need to be very careful while using these metrics, because they just give you generic answers, and for you might care not you might not care so much about like how comprehensive the retrieve context is, but you're caring about a very customer specific case. And I have encountered some cases where these metrics give me very high answers, and ultimately that's not really relevant, because the answer might not be like the right answer. So there are various tools that you can use. So one of them is like Uptrain, and there's various startups in this area, because it's a very important topic, and ultimately I think a few startups might win, or yeah, it's hard to say. But I think LLM as a judge is here to stay, and that's something that is exciting, because based on your industry use case, you can tune your LLM as well, right? And you can tune it to be more similar to human evaluation. So how do you structure evaluations for optimization? Well, first, what you do is, you define the use case and develop your V0 app. And then you evaluate your V0 app on a few outputs, iterate on it, modify the prompt, modify the RAG strategies, and then deploy this model into production. Continuously monitor the performance through user feedback and moderation. And then you again modify parameters and add features as needed to improve performance. Then you can do a direct comparison between V1 and V2 responses on the same data. And then finally put V2 in production if V2 is significantly better than V1. Right? Any questions so far? All right, so now I'm going to move more into the optimization realm of things. I'm going to talk about automated prompt optimization, which is a very interesting field. So reason being, as you start to develop more and more prompts, initially the prompts are straightforward by the use case, right? But you will start to very soon encounter more and more complex prompts. And then once you start to do that, you will start to see cases where um, you're starting to essentially try to be an English master, and you're trying to capture so many things while you're engineering prompts to make sure the quality is good, um, the consistency is good, that it's reflective of the customer's needs, things like that, and reflective of industry best practices. And when you start to see all of this, uh, it's like you're juggling an entire complex model in your head, and you're trying to write it out in plain English, and it starts to become a little bit ridiculous, and also like just very inefficient, right? Because the whole point of LLMs is to make your life easier. One of the big points to automate things, and then now you're doing this handwriting of inputs to the LLMs or the LLM prompt for it to do its job. So there are various techniques for automated prompt optimization, which are taking these prompts and moving it towards this machine learning realm of things, where you're trying to fit a line or fit a model over the prompt. It's very straightforward in terms of like the idea where you have an input question, you have an output answer, and you want to fine tune a prompt. You have a function of the input and the output. You want to find that function, right? Um, and so you have an initial prompt. Um, you put that into DSPy. You have the output answer, and then you have a final prompt that is tuned based on that. Does DSPy consider for which LLM is generating a prompt? Intrinsic implicitly does, because you're using the LLM to generate the output, and so it'll tune that LLM for that prompt. Yeah. And DSPy has various metrics as well. Yeah. So if you use Claude as the LLM in DSPy, it'll fine tune it the prompt for the engineer it for Claude. So yes, DSPy should do that under the hood. And yes, your final prompt should be different for Claude versus GPT. I haven't tested that out myself, but I think that'll be I'd be very curious. Yeah. So this is a DSPy example. I have I have something here that I can share. Um, yeah, please, have a look at that. I'm just going to share my screen. Right. So this is basically a prompt for extractive question answering. So let's say you wanted to answer questions from a context, but only extract it. So if the answer is not present, like within the context, don't answer it, but only answer with some string in the context, right? So let's say, for example, here, um, I have a prompt and I say, answer questions with short factored answers following the following format, question, answer. And then this is the output answer, need more context. This is not good, I think. You would want it to stay just like it's not in the context or something like this. So if you just walk through this example, you will see that DS5 takes into account few shots and is able to, very similar to PyTorch language, use this concept of a teleprompter to optimize your programs. And then finally, this is a context about movies. So finally, it's able to say, like, if it's not there, answer not found, and it incorporates both chain of thought and step-by-step reasoning. Um, yeah, and through DS5, you can incorporate various different kinds of metrics as well. You can even take into account like an LLM judge, uh, which now then DS5 will try to make a prompt to satisfy a judge. Any questions so far? Yeah, you can walk through this blog and you can see all the various data that's in there. And, as you can see, through DS5, you can actually make a large language model like similar to the machine learning data, where now you're differentiating between trained data and test data. You're training it on the trained data, and you're hopefully seeing improvements on test data. This is still early days, I would say, just because um, I would say for some really trivial cases, uh, it's either two spectrums. One spectrum is you have really easy cases are very clearly defined. So we have two different document parsing strategies. We have adding this to this quadrant database. We have re-ranking, and then we have hybrid search. And then finally, for evaluation, there's ground truth evaluations where I used an LLM like Claude to generate input-output pairs for the ground. And finally, I have 57 ground truths and get 4 different results here. The last one is the hybrid search. And so the hybrid search seems to be doing really well in this particular case. Right? It could be different based on different use cases. And then finally, I'm just looking at non-ground truth eval using deep eval. But this is where what I said earlier was that, like, all of these seem to be getting very high values of like relevancy and all these other metrics. So you need to be very careful when you're using just generic non-ground truth eval metrics. Okay, any questions? Yes, that's a great question. I would say if you have PDFs, the best chunking strategy would be page by page. Um, I mean, even though it sounds very simple, it's very intuitive just because one issue with like, unless the page has too much of text, right? So one issue is that if you have these very small chunks, you have half the table in one page, in one chunk, and half the other half in another chunk, and that starts to have issues because with reading content from tables. There are other chunking strategies. So like um, typically you would it depends if you have answers that are like, let's say you ask certain queries where the answers are going to be distinct parts of the text, but they're going to be in multiple aspects, then you would need short chunking strategies. But if you are pretty sure that each answer is going to be based on the questions that you ask are going to be localized in certain parts, but they need a lot of context to answer, then it's better off having large chunks. And I think Pinecone had a very good learning there, something like that. Move to the right section. All right. So now we're going to be talking about scaling and deploying LLM apps, right? So, before we talk about it, um, I'm sure a lot of might be actively running things in production, but just sort of as a comparison to what we've talked about before, uh, I'd like to just mention a shift in mindset. So in production, the number of choices that you have exponentially increases as compared to when you have prototypes that you're testing on, right? So, as an example, for our prototypes that we discussed for RAG, right? We looked at prompt engineering. We looked at various um, document parsing strategies and various retrieval strategies. And so these are things that you can actively test out and find the best option, right? But in production, there are so many things, and you don't necessarily have the time to test out all of these various options. And it could also be very expensive, right? So which cloud provider, which vector database, how to serve applications, uh, should you use AWS or Google, things like that, and how do you handle errors, costs, uh, performance edge cases. Um, but ultimately, you need to start from the customer business use case, just because you can spend a lot of time optimizing for going into production, but then you have nothing to really show for it, especially if it's not aligned with the business use case. So I like to highlight this agile approach, which has become, the norm. So more important than being right the first time is to find appropriate success metrics and keep making continuous improvements towards these metrics. So let's keep this in mind and let's look at various methods and tools for deploying LLM applications. And then hopefully in the future, you can take some of this knowledge and then bring it together for your own goals. Okay. So the first thing is database and storage. And we talked a little bit about some common database choices. So yeah, PG Vector is a good choice, and then there's Pinecone, VBA, Chroma. I would just, and a lot more, right? I would just say, you can choose what makes most sense, and it's probably going to be a good enough choice. You're not going to get too much difference, if you move from one to the other. Um, and the important thing here, though, is how you architect these databases. So these column choices are critical. What are you embedding? Are you also incorporating some metadata like keywords to help you search on the document type, or let's say like the reference URL, things like that. You need to find solutions to store other types, images and tables and audio, etc. And then of course, like cloud providers are usually good for hosting databases. And there's actually an interesting debate in the field about these vector databases. Ultimately, these very specific providers, are they just going to be eaten up by cloud providers like AWS or Google or something like that, just because these cloud providers have their own vector database solution, and if your data is already there, they make it that much easier to just like transport very easily. So this is the basic vector database and querying architecture. We went through it a little bit before, but the idea is that the user poses the query in one, that query is fed into a DB, and you retrieve a document accordingly. We can use parameters like top k to get k retrieve documents, where k could be like 1 or 5 or 10 or something like that. And then you do an API call to the LLM in step 3, and then finally that generates a response that is sent back to the user. An important thing is model quantization, which could make all the difference between hosting your own open source model versus using a closed source model. It makes things much cheaper, right? So let's calculate how much memory is needed for putting a 10 billion parameter model in GPUs. So if each parameter is 32-bit or 4 bytes, which is typical, then a 10 billion parameter model would mean a whopping 40 GBs, right? Which is a lot of memory. It's like an E100 or something like that, right? Or maybe a couple of them. Whereas the 1 billion parameter model would require 4 GB memory. And there's a typo there, 100 billion would be 400 GB, right? So, but if you are doing things like converting 32-bit to 16-bit, which is now routine, then that 40 GBs gets slashed to 20 GBs. Or if you do 8-bit quantization, it becomes 10 GB. And so there are various quantization methods. Some of them are very just easy. So things like GGML or bits and bytes would mean that essentially you're just like, right word, you're just finding the closest floating point number. So you just lose that much of precision. And of course, that means that the output quality is reduced. But there are various ways of improving, making sure essentially that the output quality does not reduce dramatically. And there are companies like GrokQ that do this. And there's also other, GPTQ, which is like these training-aware quantization methods are becoming more popular, where they're a little bit more sophisticated. And so you can get the benefit of lower footprint, but at the same time keep a lot of the accuracy. Just looking for questions. Yeah. Another important aspect is moving to prod is having your own APIs. So AWS and Hugging Face makes it easy to deploy your own APIs. And the serverless strategies also handle concurrency, et cetera, under the hood. And so we're going to walk through an example where essentially we will look at deploying this like older Dolly model from Databricks. This is the approach we take: is find the model on Hugging Face, deploy the model, and then use AWS Lambda to deploy it as a serverless API along with an API gateway. Right. So I'm going to share my screen right now. Okay, so I have this notebook on SageMaker here. What I'm going to do is I got this from Hugging Face. Find the so that you can see it. Essentially, this is the model here, and if you click on deploy, you can see deploy with SageMaker. And what I've done is I just copied this and pasted it here in SageMaker. Right? So I should actually run this. Um, what it's doing under the hood is it's taking all these files, and SageMaker has the relevant like um, requirements in container, I believe, where it can just run this and publish it as an endpoint. Okay. And again, this is like a 7 billion parameter model. Um, so this is going to take a while, but so for the sake of this example, I'm going to actually look at a smaller model, which is this DeepSet Roberta based squad model, which is for extractive question answering, as you will see. The important thing here is to define the kind of instance type. So ML.M5X large. This is just for CPU inference. There's no GPU in this case because it's a smaller model. And let's wait a few minutes for this to get done. All right, any questions so far? The notebook which you showed just now. Which notebook would it be? Is it the AWS notebook or is it a RAG notebook? I have a notebook here. Oh, yes, I see. So this, I will not be able to share this notebook just because this is in my AWS SageMaker. But the idea is to just go in here and, in this case, it's like, look at this any model. So uh, let's look at this DeepSet Roberta-based Quad 2, and I'm just going to click on this, deploy with SageMaker, and then just copy it. So that's all you need to do. And then you just need to run it. So it's finished running here. And let's say, what's my name? My name is EDF. I live in Berkeley, so it gives you the score, which is like what's the probability of the answer. It gives you the start. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here, and the end. So it's like 3 characters. So it's 11 through 14. This is for extraction again, and then the answer. So while this is great, you cannot access this outside the notebook, right? Um, so now what I'm going to do is I'm going to go back here, um, SageMaker, and then I'm going to go to endpoints. And if you see, you'll see, okay, that this is an endpoint that's been made. The next step is for me to go to AWS Lambda, go here. Look at the endpoint name. It's going to be different. I'm going to copy this endpoint name. I'm going to edit it. Save it. And then test it. As you can see, it's equal to yes, probably. So I can say where do I live? Right. So this is the first step, which is to put that endpoint through AWS Lambda. So it's a serverless endpoint, and so that it can handle various loads accordingly. Right? And then finally, the last step is to go and make it into an API gateway. And that's the third service that you need to go into. So you go into API gateway. I need to define a post method. And I can try to test it. Try to test it. Okay, I'm already deployed it, so let me see if that works. Oh yeah. So yeah. So right now I have already connected that. You see, it's already connected to the Lambda. And then if you go to the Lambda function, you can see here that it's already connected to this API gateway, which is exposed. So now, if you actually, like if you go to that notebook that's here, the LLM intro, and then I'll also paste it here. You can try this out right now. But essentially, I go to a separate notebook that is not connected to SageMaker. And if I ask this question, it should be able to get the answer. Right. So do I have food? In this case, it gives you a very low score because it says I have many friends. So do I have friends? Yes, I have many friends. Many friends, right? Is everybody able to test this? You can use this endpoint there, um, and then let me know. Has anybody tested this request out using Python? You can test it out either on Google Colab or use my same notebook at the end. There's AWS API thing. Okay, great. Yeah, you can use the curl command. That's perfect. Okay, awesome. All right, I'm going to leave it open for a little bit and then turn it off so that it doesn't start. Okay, great. So we created our own API. Yeah, so that's awesome because just think about it now. We can deploy this, in a website, right? And then you can have somebody query and ask questions, right? So it can be your like first basic application. All right, so we deployed this to an API. We didn't have to worry about anything. Uh, SageMaker took care of all the requirements for us. But you can think about it as what you need to make this run. You have the model itself, which is like a Roberta model. You need to use Python, uh, maybe PyTorch, transformers, etc., to actually call the model and then serve the request, right? So containerization is this idea to ensure that code runs the same no matter where it's run. So how did we make sure that the code ran on SageMaker just fine? Well, we probably need something like Docker um, that has all the requirements. And then so you can essentially have a Docker image that can be hosted and run on the cloud. Apart from Docker, there's another orchestration layer on top of Docker, which is called as Kubernetes, which assigns resources as needed to Docker containers. So this container, for example, might require less memory as compared to like if you have a much larger language model, right? And then you might need more resources during peak times as compared to not. So Kubernetes helps orchestrate these, as well as orchestrating flows between multiple containers. And then you need a way to have continuous integration and delivery. So GitHub is a way for continuous integration. And you've probably used GitHub or GitLab or something like this at work, where developers are collaborating and you can have history, and it's very important in production to like keep track of everything. Um, and, and then you also have Jenkins or other automation servers that automate the flows between Git to the cloud and to deployment. So you can basically you make a change in Git, and then that ultimately causes a new API to come about. So let's say you're having the same API here, but you're changing the model, or you're changing something about the inputs. You can do that in Git, and then ultimately the API gets like automatically updated. The other idea is to have cron jobs that run at a regular interval. So, for example, if you have a vector database and you want a daily pipeline to incorporate new data into it, right? You would need a cron job for it. And again, like when you put all these together, these ensure that you have a good application and good performance. In of itself, they're essentially just tools that you need to. The hard part is putting all these together, and that's why you need multiple folks and multiple teams together. yeah, I think you can use GitHub Actions instead of Jenkins. You know, you have just so many options and ways of doing things. I worked at a place that has Amazon that uses AWS cloud, and then another place that uses Google cloud, and there are a lot of differences between the two, but ultimately, like they both can do the same thing, which is to make your machine learning pipelines, like deploy them and make them scalable. It's just like different ways of getting to the same thing. The other important aspect is to orchestrate ML workflows. So managing and tracking experiments, um, and then connecting between, you know, the GitHub and these models, and finally the user. You know, things like Apache Airflow or the ML Google equivalent, which is called as Kubeflow, helps automate things like that. So let's now talk briefly about you know, what could change in prod and what could go wrong. Um, so you could have something like data drift coming in, um, where the production data is different from the data that's originally trained on. Um, you could also have like data quality issues, so like bad data inputted, JSON schema issues that somebody was mentioning. If you don't have a good prompt, you can have JSON issues, you know, too much of a volume, performance degradation, things like that. So it's very important to monitor these things in production to make sure the user experience is good and there's no drop off. Um, so it's, you know, when you, there's a lot of ways to monitor traditional applications. Um, Monitoring LLM applications introduces some nuances. For example, you might see if inputs are substantially changing from average, um, or like if bad answers are being detected, monitoring things like that, or having a classifier for not allowing um, bad outputs or unethical outputs, profanity, things like that. And also monitoring for code failures. Um, and you can also use LLM as a judge. And then finally, costs are also important for it. So how do you evaluate and prod? You can have customer feedback, um, and then you can look at LLM as a judge and the rating of the outputs. You know, retrain on edge cases. So for future improvements, it's like I was mentioning before, it's important to evaluate the new versus the old model, and then finally put the new model in production if it's better, and then keep repeating this at some regular cadence. Here are just some tools to monitor LLMs, LLM applications. One of them is YLabs, um, and then there's something else called GISCard, um, which is for using it as an ML testing library, um, for debugging quality and monitoring some hallucinations and toxicity. I put this a while back, but there are even more coming out now for monitoring LLMs. Any questions so far? What could be possible impact of overfitting? Oh yes. Anecdotally, I have come across cases where, to your point of overfitting, you might have like a high value customer, and then you would say, "Oh no, this customer does not like a certain aspect of the LLM. Let me go and add this specific thing to the prompt," and it's like just very tailored to that customer, and it results in a very bad experience to other customers. Um, it's a hard problem for sure. It's very hard without good monitoring to figure out whether your app is doing well or badly, and like how do you make improvements to it. So yeah, so something that you've got to take care of. Yeah, and traditionally, overfitting is done, of course, with the test train sample. But I think your question is more of specific customer use case. But this is also where things like RAG helps, because then you can tailor it to that customer. So let's say if that customer is not happy with some generic outputs, now you can tailor your application to that customer's data, and some other applications to one other customer's data. Um, and so that will make it much better. And are these tools available in AWS? Well, you can make them available. And that's the beauty of things like Dockerizing and containerizing. So these are open source applications. Go ahead and Dockerize it and put it in AWS. It would be a slightly different approach where you would still use AWS Lambda, but maybe not as easily as SageMaker. You would need to put this in some other way called like an Elastic container service, where you can host Docker containers and make them available through Lambda. But also AWS has access to some closed source things like Pinecone. But then again, like you can either use it through AWS and get a dedicated endpoint, or you can just configure all this in your Pinecone dashboard. Yeah, so you have multiple options. So all of the stuff that we talked about was sort of LLM ops level 0, where like if you basically just deployed one model and it's going to run in production. But then level 1 is now sort of, let's see what's going on in production. Let's like rapidly iterate it and improve it. And then even going forward, there's this whole continuous delivery of models, where let's say you're able to automatically get customer inputs and outputs and use that as new training data, and your app just becomes better and better. Yeah, so then this is basically the V1 pipeline, which is it's coming from a Google concept for ML ops, level 1. I just modified for LLM ops. So you have the data, you train it, you deploy it, you monitor it, get more data, and that's you have this flywheel. And that way you can ensure that your application is not stale. Of course, this is easier said than done. And always you need to experiment and make sure that it's worth the extra effort to actually have this kind of more automation. All right. So now we're going to, okay, is it possible to roll back, or is that a percentage? Is that a percentage like a typo, or is that real? Is it possible to roll back or deploy a new model? Yeah, you should engineer it in such a way that you can always roll back and deploy the older model. That's the best practice, because you never know what happens. This model could be doing extremely well, that's in the staging environment, but you roll it out and it just takes too many resources, right? And it just gums up all the traffic and destroys your whole application. Then you need to immediately roll it back to the older model. Okay, so now what we're going to do is we're going to look at something called LM Studio, and you're going to try to run it locally. So this is where you're going to be able to deploy your own model on your laptop or desktop or whatever system you have. So I'm going to paste it here. So please have a look at this video and try to download LM Studio for your machine and run it. Let me just go to the website. And I'll give you a few minutes to download LM Studio and to get familiarized with it, and then we'll sort of walk through it. Oh, I don't know what model this is. So it's like an older Llama model, I think. Oh, okay, so it's still giving answers. That's good. Popular and lesser well-known destinations. Okay, that's good. How are the answers returned? These are just some things to think about. Also, Llama 2, yeah, it's very interesting. You have yeah, I was very puzzled that you were getting the exact same answer that I did. Um, yeah, cool. Um, Yeah, also Llama 2 would give the exact same answer. Try asking GPT, see whether it tells you what this laws program. Okay. All right. So we're almost towards the end of the course. Lastly, um, since we have some extra time, we can walk through sort of an application end to end that is hosted on Heroku, where Heroku is essentially it's it's a platform that's very easy for deploying applications. It makes it easier for like if you're tinkering with things, but also it's Heroku servers are on AWS, and so you can imagine it's just more expensive. So it's easier to get started, but it's a little bit more expensive. So again, I'm going to sort of walk you through um, this repository that I had before for optimizing RAG, but now it's basically like deploying the RAG application um, and I can show you how the final application is. Okay, that's called document Q&A. What you do is you upload a document. You can try this out. Um, yeah, I'm going to quit LM Studio because it's crashing my computer. I'm having some issues. I'm just gonna. Can everybody still hear me? Okay. My screen has suddenly become very small. I was just not able to see anything. Yeah, I'd appreciate some thumbs ups.